Ja, hjärtligt välkomna till andra programpunkten i den här temadagen om diagnostik. Och jag kommer nu gå över till engelska för att bjuda in vår Keynote Speaker. So, welcome everybody to the second program session in the full day program on psychiatric diagnosis. And at some stage during your career, sometimes you start to think, what is a psychiatric diagnosis? What is it? We use it in our everyday language and we sometimes find it self-evident what it is, but really it isn't. And last year or the year before, I found a book which was very interesting in this subject, In Defense of Psychiatric Diagnosis. And I found it very illuminating and deepened my understanding of how you can look on psychiatric diagnosis. And we discussed this in the Swedish Psychiatric Association and decided to invite the writer of this excellent book. And it is Sam Fellows who we have invited, Associate Lecturer at the Department of Philosophy, Politics and Religion at the University of Lancaster, UK. Very welcome. The floor is yours.
So, thank you very much for inviting me, and thank you for coming along and being able to listen to me in English, which is quite a novelty because I know about 2 Swedish words. So yes, I'm a philosopher. My background is in philosophy of psychiatry and philosophy of science, and as much as I'm sure you yourself have spent a lot of time thinking, what constitutes a good diagnosis, which is a broader question of what constitutes a good scientific theory, good scientific entities. These are questions which philosophers of science and philosophy of psychiatry have questioned, and we've analysed this in relation to psychiatric diagnoses. And I'm going to look at one way to understand this. Are they real? Do they exist? Is autism real? And then I'm going to suggest that is the wrong question, and I'm going to outline an alternative question. So firstly, here's 2 quotes. On the right-hand side, these aren't from philosophers. DSM psychiatric diagnoses are, quote, unscientific, made-up constructs voted into existence by the opinions of psychiatrists populating the DSM committees. So this is Jo Watson. She's arguing for a psychotherapeutic approach. She's saying DSM diagnoses, autism, schizophrenia, major depressive disorder, these things aren't real. We've made them up. They don't actually exist, and so we should stop using them. Let's use a person-centered approach. And similarly, quoting John Reed, to say that schizophrenia does not exist is not to say that some people don't have experiences that are very unusual or difficult to understand, or who suffer extreme distress or confusion. So John Reed is saying, yeah, there's people out there who have various symptoms, and we should try and help them, but we shouldn't say they are schizophrenic because schizophrenia doesn't exist. It's made up. Whatever's going on, it's more complicated than schizophrenia, whatever's happening in reality. And so John Reed argues for a dimensional approach. So as mentioned, philosophers have spent a long time thinking about existence and reality in relation to science. And I want to sort of outline how they thought about these issues and then apply it to psychiatric diagnoses and then go on to the alternative of saying this is a wrong question. We should understand diagnoses as being idealized and abstract models. So philosophers of science often look at the history of science. And when you look at the history of science, you find quite a lot of theories that people believed in at the time but turned out to be wrong. So this is the 2-sphere universe. This is where the Earth is the center of the universe, and around it go all the planets and the sun. And this was around for thousands of years. And the interesting thing is that it was actually based upon a huge amount of astronomical evidence, and it could actually make some very impressive predictions. And yet, it was completely mistaken in its central claims. Also, for example, you had the ether. So in the early 1900s, there was a lot of discussion about the ether, the electromagnetic ether, the optical ether. It was basically the idea that things like light and electricity travel through this medium, almost like you have water and you push water when something moves through it. Similarly, that's how electricity moved, that's how light moves. And that's not what happened. This was based, again, on a huge amount of evidence. It made some very impressive predictions. But ultimately, as far as we can tell, this ether thing doesn't actually exist. So there's an example of a theory or an entity that don't exist. 1800s, phlogiston in chemistry. The idea is when a chemical reaction occurs, this thing called phlogiston was given off. And there was a huge debate about this. And again, it turned out this thing doesn't actually exist, even though there was a huge amount of scientific research into it. Cosmology, steady state theory in the 1950s, 1960s. This was the contrast between the debate was steady state theory, whereby the universe has always existed and matter keeps renewing itself, versus the Big Bang, where all matter just turned up in one particular moment. Lots and lots of debates about this, loads of evidence for the steady state theory. It made some impressive predictions, but as far as we can tell, it's wrong. And then if you look at something like history of psychiatry, you had things like hysteria. Whatever was going on with people who got diagnosed with hysteria, it wasn't hysteria, it was something more complicated. For example, theoretically, the refrigerator mother, that autism was caused by poor mothering. Now, I also work on the history of autism. Things are a bit more complicated than that, but some people did, to some degree, believe this. Again, here's examples of things that are wrong. So the question is, might we understand diagnoses as being wrong in this sense, that autism is wrong in this sense? So let's look at some current debates about things that may or may not exist in science, things that we can ask if these things are real or if they exist. Electrons. Why might you think electrons don't exist? I'm not saying they don't, I'm just saying why might you ask critical questions about this? Because they're incredibly small. We can't see them directly. They're in fact smaller than light. And so you might ask, well, if we can't see them, how do we know they're there? We can certainly see things going on in laboratories that may be caused by electrons, but maybe what's going on in reality is actually very different. And indeed, if we think about quantum theory, well, the typical image we have of electrons, or at least in the UK anyway, when I was at school, is it's a whole bunch of balls circling other balls. Quantum theory gives a radically different image of what's going on, and it's really not clear what even an electron is. Or tectonic plates. So the thing about them is they're so far under the earth, we can't see them. We've never actually been down there. They certainly are compatible with a huge amount of evidence, and we can use them to make predictions, but you can at least sit back and say, well, are we sure they really exist? Dark matter in physics. So there's lots and lots of theories that work really, really well in most domains, but those theories predict there should be a certain amount of a certain amount of matter in the universe, and we don't find that amount of matter. We find much less. So scientists have posited this dark matter. That's what we can't find, this almost indetectable dark matter. And so we got the question of, does the dark matter actually exist, or are the theories wrong? Rational choice theory in economics. So the problem with that is that lots of people aren't rational when they make economic decisions. Is this actually true? And then to take, for example, two things from psychiatry, which you'll probably know a lot more about than I do, dopamine hypothesis, serotonin hypothesis. Are these things describing something real or not? I'm not saying these things do or do not exist, I'm just pointing out that it's the sort of things that we can have debates about and wonder about. And you might look at this and say, on balance, electrons exist, tectonic plates exist, dark matter doesn't exist. So it's this sort of discussion of what exists and what doesn't. Could it be the case that DSM diagnoses, autism and schizophrenia, don't exist in the sense that the ether didn't exist? Or don't exist in the way that maybe dark matter doesn't exist. These theories, they're compatible with a degree of evidence. They can be used to make some sort of predictions, but whatever's actually going on in reality is radically different. So that's sort of setting up this question of existence. And philosophers have asked whether DSM diagnoses exist. And the main model they've used to understand this is biological species. So, if autism exists, if schizophrenia exists, if major depressive disorder exists, they would exist in a similar manner to biological species. That being, there are these entities out there that have quite a lot of similarity because they have an underlying biological similarity. Not identical, but sufficient similarity. This is a main model which philosophers have used. And as it happens, it looks like diagnoses in the DSM don't fit this model very well. So if diagnoses existed, they would be like biological species. They don't appear to be like biological species, therefore they probably don't exist in any sort of concrete sense. Whatever's going on in reality is going to be different. That's to what we find in the DSM. That's the basic argument. So 4 reasons for thinking this. Virtually all diagnoses in the DSM are very causally heterogeneous and behaviorally heterogeneous. 2 people can get the same diagnosis of autism and yet have quite a lot of differences in the symptoms they exhibit and in the underlying causes. And that happens to a much higher degree than you find of biological species. Yes, no 2 dogs are identical in how they act behaviorally or in what causes they have underlying them, but at the same time, there's a lot more similarity compared to something like autism, or so the argument goes. Secondly, in relation to diagnoses, there's a lot of unclear boundaries and a lot of overlappingness. So where does autism start and then end, and where does normality begin? Where is the barrier between autism and normality? That's a very difficult question to answer, to say we can definitely point to it should be here, because of course we can model autism as extending across the entire population, as I'll talk about later. And similarly, overlapping diagnoses. Where does autism start and end, and then where does ADHD begin? Where should the boundary between these 2 things be? And the basic intuition is there's far too much difficulty in answering these questions. We can't give clear answers to these questions, and that's not how things should exist. So you do get these issues again in relation to biological species, but to nowhere near the same degree. So you can get like crossbreeding a lion and a tiger. So what's going on? Is it a lion? Is it a tiger? Is it something new? But these are massive exceptions. They're nowhere near as problematic. So again, if this is the intuition, things in the domain of psychiatry would exist like species do. Well, diagnoses don't seem to be like that. Also, diagnoses are a product of a decision-making process. So it looks like we need to, in a sense, decide what autism is. So if we take the diagnostic criteria for autism, there's 2 main lists, and you need a certain number of symptoms on each list. Should we need 4 symptoms on each list? Someone's got to exhibit 4 in one list and 4 in the other. Should we need 3 on each list? Should we need 2 on each list? Someone's got to make that decision. And indeed, which specific symptoms should be on that list? So we can, for example, make it overlap less with ADHD. We might remove some symptoms. And there's a process of the DSM committees actually making these sorts of decisions. Granted, after reading thousands of papers, or at least some people are reading thousands of papers and then feeding this into various committees. But in principle, it does look like there is a level of decision-making going on. And also a process of changing mind, people changing their mind. So there used to be 3 different lists which you needed symptoms on in relation to autism, and then it got reduced down to 2. We used to have high-functioning autism, low-functioning autism, Asperger's syndrome. They all got rolled into one thing. So people seem to keep changing their mind, and the general intuition is that there's no way, whatever's going on in reality, if we were tracking it, there wouldn't be this level of decision-making. There wouldn't be this level of people changing their minds. I mean, people have had ideas of dogs and cats for literally millennia. You know, the ancient Egyptians didn't spend ages trying to work out what's a dog and what's a cat. Where did dogs begin and cats end? It just didn't happen. And so it looks like that doesn't really work. And then finally, and admittedly I think this is potentially a bit of a weaker argument, but it's certainly one that's made, is that DSM diagnoses miss out crucial aspects of people. So where somebody was born, well, so who their parents were, what relationship they had with their parents, what their school was like, do they have a job today, do they enjoy their job today, do they have friends, do they have a relationship, what's their goals in life? What do they want to do? All of these things are massively psychiatrically relevant for their mental health. And yet, if you know someone is autistic, that doesn't tell you, oh, they have this relationship with their parents, that they love their job or they hate their job, that they've got this goal or that goal. It just doesn't tell you that sort of thing. And so the idea is for autism as a diagnosis, sorry, that's the one I always come back to as the one which I research. And for context, I've actually got a diagnosis of autism myself. As we'll see in a moment, I'm going to defend these diagnoses. So autism just doesn't seem to be really getting to the core of people. Now, admittedly, you could potentially say that's the same with dogs and cats because, of course, dogs and cats are quite different. But I think the idea is that if someone says to you, oh yeah, can you look after my dog? That word, and you say it's a Labrador, that's already conveying a huge amount of relevant information. Whereas if someone says to you, oh, my friend's autistic, that's not really giving you as much information. So the idea is that, again, something like DSM diagnoses aren't tracking whatever's going on in reality in the way that biological species are tracking whatever's going on in reality. And so philosophers have generally said DSM diagnoses probably aren't real. They don't exist in the way that we might think scientific entities exist. Some philosophers would say, well, that's because there are these things out there that we could discover, these diagnoses out there that we could discover. We've just not discovered the correct ones. So something like the DSM could work, but we've got the wrong diagnoses. Other ones would say, well, maybe just the whole idea of the DSM as a categorical system, it just needs to get rid of. Okay, so that's one way of approaching this issue. I'm now going to outline why I think this is the wrong way and make a big contrast with an alternative way of thinking about this. That being diagnoses as modeling. Now, just for context, oh no, sorry, I missed a slide. Another issue about diagnoses is that we can do psychiatry without ever mentioning DSM diagnoses. So there's alternatives. For example, there is, at the top, hierarchical taxonomy of psychopathology. This is a relatively new research group that basically wants to take the domain of psychiatry and study it and then apply statistical methods and come up with new groupings. But these groupings will be dimensional, so rather you've got the diagnosis or you don't, the people are going to have it to a degree, and also it's going to be hierarchical. So you have a sort of a higher order construct, then you might have a lower order construct which links to another one. I'll actually have a more discussion of this towards the end. They have not found an autism or schizophrenia. When we did their big statistical analysis, they didn't find DSM diagnoses. They found other things. Similarly, you've got research domain criteria, RDoC. That's been going on since I think it was 2008. And its basic idea is to try and chart what's going on in the domain of psychiatry, looking at the causal level. And the key thing they look at is transdiagnostic mechanisms, i.e. a mechanism that occurs in many different diagnoses. So rather than just looking at, let's study the autism and look at what causes are going on in autism, it's a case of let's look at this cause, and that cause might occur in autistic people and schizophrenic people and ADHD people, and nobody cares about that. They're interested in tracking the causes, not the diagnoses. So again, you can do psychiatry without using the DSM. And then, of course, person-centered formulations, let's look at the individual person. We don't need to then say, you're like this, and you're like that, and you're like this, therefore you're autistic. Let's just focus on the individual. So here's the other argument against DSM diagnoses. We can do psychiatry without ever mentioning any DSM diagnoses. And so there's a possibility that maybe what's real is not the DSM, what's real is what's Hitop's discussing, or RDoC, or person-centered. But like I mentioned, I think this is the wrong way to think about it. So as mentioned, I recently published a book last year in defense of psychiatric diagnoses, but also interestingly, 2 other books came out last year, also about modeling in psychiatry. So there's Adrian Kind, How Does the Psychiatrist Know? That's about which diagnoses someone should get. That is an act of modeling. And then on the right, you've got Douglas Heinrich, How Psychiatrists Make Decisions. That is the idea that when you make treatment decisions, we should understand this as an act of modeling. Now, we all wrote these things independently. We didn't know each one was writing these until we'd all published them. So there's an interest in psychiatric diagnoses and modeling, which were all written independently. We do have a joint paper under review. What is the alternative way to think about this? And that is scientific models. The alternative way to say is when scientists do science, they often employ scientific models that don't actually really fully reflect what's going on in reality, but that's fine. That's how science works. And if we understand DSM diagnoses as one way of modeling, we can actually see how they can be potentially useful, providing we also employ other models. So what is a scientific model? Two examples I'm going to give. The first one is frictionless planes, so a frictionless surface. This is where physicists look at motion, and when they work out how things are going to move, they employ frictionless planes, i.e. a plane, a surface, without any friction. Whereas in reality, surfaces do have friction. So these images here are kind of like the reproduction of what Galileo had in his notebooks. He worked out his laws of motion and stuff and mechanics by taking balls and rolling them down these surfaces of various different angles. You know, the ball, you can take the ball at a particular speed, particular angle, you can work out various equations. But when he did this, and indeed when people do this today, they assume that these surfaces have no friction, whereas of course they do have friction. They ignore this because it's so incredibly complicated to calculate. There are ways you can actually add in friction later on to your models, but still trying to track literally every factor of friction is basically impossible because surfaces vary so much. The reason why you do this is it makes doing physics so much easier. So frictionless planes, frictionless surfaces, are an idealized and abstract model that don't really describe what's going on in reality. Frictionless planes are only frictionless once we remove the friction, once we just disregard the friction. Or similarly, again, another example from physics is Newton's force laws and pendulum. So you swing a pendulum and you can work out where it's going to go by applying Newton's force laws. But this has all sorts of misleading aspects to it. So you can demarcate between idealization and abstraction. Idealization is false assumptions. We assume that the string holding the ball has no weight. It does have a weight. We assume that the string does not stretch. It does stretch. So these are all the things that Newton's theories are not covering. We assume the string is rigid. It doesn't bend. It does bend. We assume that the mass of the ball is all located in like one really tiny spot, whereas in fact it's distributed about the ball. And also there's abstractions, so that's a whole bunch of false claims. And then there's abstractions, which are things that it's just not covering. It's not covering wind speed. It's not covering air resistance. So there's another example of a scientific model. And as a third example, take ideal gas laws. So if we take a gas and put it in a container, we can work out the relationship between temperature, volume, and pressure using the ideal gas laws. These completely ignore how two gas molecules will form chemical bonds as they pass by one another. But because that's so complicated to calculate, we just completely ignore that. And so the basic point is that, in a sense, loads of things in science don't really reflect what's going on in the world, but that's fine. That's how science works. Science is great, even though that's often the case. These idealized and abstract models. So, idealized and abstract models, they make false assumptions and they miss things out. But the key idea is that when we have a scientific model, it comes from a particular perspective. It is selective. We are going to focus on this aspect of the phenomena and idealize and abstract away a different aspect, depending upon what we're interested in, what methodologies we employ, and what theories we're holding. Crucially, in science, it's best to idealize and abstract in different ways. Take a phenomena, model it in one way whereby we idealize and abstract some aspects, and then make a different model that idealizes and abstracts away different ones, and then make a third model that includes some other stuff and idealizes and abstracts away other things. For example, in relation to nuclear physics, there are 30 different models of how nuclear physics work. All of them idealize and abstract away different things. They all have a slightly different focus. And so we can get a pretty good overview of whatever's going on in reality through employing 30 different models. So, DSM diagnoses as idealizations and abstractions. So I think DSM diagnoses, we can understand them as idealized, that being they're making a whole bunch of false assumptions. Because autism is this very broad broad concept. And if you have an autistic person in front of you, they're only going to resemble a small part of it. So in a sense, to call them autism is to associate them with a whole bunch of symptoms and causes which they don't have. They'll have some symptoms and causes of autism, but they won't have the whole thing. So in that sense, it gives a very imprecise description of who they actually are. But, as mentioned, that happens in science, imprecise descriptions, false claims. Also, DSM diagnoses are abstract. To know someone is autistic doesn't tell you about their past life history, their current situation, their future life goals. It's missing something out, but scientific models often miss something out. So I think one way we could understand DSM diagnoses is they're a bit like maps. So this map, you could use this to try and navigate this particular place, but in reality, all these roads aren't this exact size, even in relation to one another. It's not the case of half the roads are really thick and half the roads are really thin. That's just not how things are in reality. And similarly, it's not covering where the shops are. It's not covering where the museums are. It's not covering where the churches are or whatever. It's not doing that. It's a selective description, which is kind of useful, but it's not giving the whole story. And equally so, if you wanted to understand what was going on in this geographical location, you'd then pull out another map that shows the contours of the ground, how high things are. And you'd pull out another map that lists where the shops are and lists where the museums are. The idea is that DSM diagnoses give us a map of people that are kind of potentially useful, but only highlight so much. There's loads of things that may miss out. So that's the first idea in which we might say DSM diagnoses are idealized and abstract models, and that's potentially a more useful way to think about this rather than do they exist or do they not. But there's a potentially stronger way in which we can think about this. So this is a more philosophical aspect, potentially more controversial part of my argument, rightly or wrongly. But it's the idea that categorical, dimensional, and person-centered are also idealized and abstract models. So categorical, you've got the diagnosis or you don't. Dimensional, you've got it to a certain degree. Person-centered, let's focus upon the individual. Rather than saying, in reality, things are categorical within psychiatry. So whatever we're looking at within the domain of psychiatry, rather than saying, in reality, it exists in a categorical form, or in reality, it exists in a dimensional form, or in reality, people exist in a person-centered form as unique individuals, my argument is we should see all these three as different ways of modeling. So what do I mean by this? So if we take, again, autism in the DSM has this big sharp cutoff point. You either are autistic or you're not if you follow the instructions of a DSM. I appreciate practically when you're diagnosing people, things are more complicated. In that sense, it's an idealization and abstraction because we're going to ignore all the non-sharpness. So when we look at people outside, there doesn't seem to be a sharp break between autism and non-autism, but we can model one in. And in doing so, we highlight connections among people who actually have these characteristics and are fairly similar to one another, and meanwhile ignore all the people who have some of these characteristics but aren't as similar to one another. We can impose a cutoff point. So that's one way of modeling. It's ignoring all the aspects of autism that aren't within people who meet the DSM criteria. But you might say that in a sense, well, can't we just say that everyone has degrees of autism? We can model it dimensionally and therefore say, well, that's how things really are. It's really a dimensional thing. To my mind, the issue with that is that, yes, you can place everyone on a dimension, but that, in a sense, creates connections that, in a sense, aren't there. Because you can have somebody, so if we take, for example, the AQA, which is a way of measuring autism dimensionally, some people are going to score 5 out of 50, and some people are going to score 45 out of 50. By saying that they're all autistic in the sense of we can measure degrees of autism, we're associating the people who have 5 out of 50, relatively few characteristics, with those who have 45. That, to my mind, looks like an idealization because we're making associations that, in a sense, you might say aren't really there in reality. And also, we can literally take any diagnosis or any system and model it dimensionally. So we can say, you score whatever on this autism thing, you are whatever degree autistic, and you're whatever degree schizophrenic, and you're whatever degree BPD, borderline personality disorders, and you're whatever degree major depressive disorders. So unless you're going to say, well, in reality, everyone is literally, to some degree, all these 300 different diagnoses alongside every other way we could formulate dimensions, to my mind, it makes more sense to say these are models. We're modeling, we're adding something on that's not really there. We're joining things together. Whatever's going on in reality, we're imposing something onto it to understand it. And then finally, person-centered, at the bottom, everyone is unique. We can model everyone as uniqueness. We can say, well, you have all these unique characteristics that are shared with no one else, or at least we're going to focus on your unique characteristics. That, again, is an idealization and an abstraction because we're ignoring the ways in which sometimes those characteristics can be present in other people. They can be there. So again, it's effectively idealizing and abstracting away all the connections between you and some other people that may actually be there. So my argument is, rather than saying, in reality, the domain of psychiatry exists categorically, or in reality, dimensionally, or in reality, person-centered, these are 3 different ways of modeling. They're 3 different ways of giving form to the world of psychiatry, of creating a level of simplicity in where we understand what's going on in reality. So just as we might take nuclear physics and model it in 30 different ways, these are 3 different ways of modeling what's going on, of giving it structure, of giving it form, of highlighting connections. Whatever's going on in reality, we model it in a way that highlights some connections and ignores other connections. That's the basic idea. And so something like DSM, and then HITOP, the hierarchical taxonomy of psychopathology, and RDoC, research domain criteria, and person-centered, rather than saying, oh, well, one of these is correct and all the others are wrong, they're different ways of modeling. They're different ways of trying to understand people. And as mentioned earlier, all models are incomplete. No model is giving a full account of reality, so we should create multiple models. And so to my mind, we want to employ all of these. We want to employ all of these different models when trying to understand people, rather than saying, oh, well, in reality, I think the DSM, those diagnoses don't exist. I'm going to say HITOP things do exist. Let's use multiple models. Now, so this is the actual hierarchical taxonomy of psychopathology. This is from the 2013 by Forbes et al. It's an excellent paper. This is actually how it works. I just want to briefly state exactly what I think something like a categorical system can actually add on to this. So in your HITOP system at the top, you've got the superspectra, and then underneath that you've got the spectras, and then underneath that you've got the subspectras, and then you've got these subfactors. So someone might fit within one of the top spectras, and then from there you can fit them into one of the other things below that, and then you fit them into a couple of these. So someone might have a couple of these, for say 3 of these, 2 of them, and then 1 at the top. And it measures everyone dimensionally. It tries to understand how everyone has all these different things dimensionally. And I think this is great. I think we should use this HITOP system. I think it's really excellent. But it's a dimensional system. So why would I think a categorical system could add something on? So I don't know if anyone can actually see this at the back. I apologize if you can't. I've just simplified the table to focus on the bits that you might associate with autism. So if someone was autistic today, they would fall under the neurodevelopmental and cognitive difficulties spectra, okay? And then they'd probably fit into the neurodevelopmental, so you can measure them dimensionally on this big subspec of spectra here. They'd probably fall quite heavily onto this one, the neurodevelopmental subspectra, and we'd model them dimensionally on that. We probably might have something in here, score lower on these dimensions. And then from there, we can then measure them dimensionally on these things. So social communication difficulties, ritualized behavior. And the idea is that this isn't going to track autism. You're going to get some autistic people are going to end somewhere over here, but you also might end up somewhere over here. Some ADHD people are going to be quite heavily into here, but probably more over here or whatever, stuff like that. So it's not going to track the DSM diagnoses is going to be an alternative way, and potentially a better way in some regards, because it's going to take all these different aspects and model how someone fits within this whole system and have these dimensions. Why would I then say, oh, but given how good this system is, and I do think it's great, why would I then add on categorical diagnoses? So I think the short answer is that they can give us a further level of resolution. This is like looking at the world in one level of resolution, and this is great, but we can add on some slightly more specific resolution. So for example, somebody might score relatively highly on this one, social communication difficulties, and score moderately on ritualized behavior. Whereas what we would call an autistic person would probably score highly on this one, social communication difficulties, and highly on ritualized behavior. Why would we then want to demarcate this as a specific thing, someone who scores highly on these two things? Firstly, symptoms interact with one another. So it's not just a case of you've got loads of symptoms of social communication difficulties and loads of symptoms of ritualized behavior. You have these, and they interact with one another to create further effects. That's one reason, and that's the sort of thing you can track via more specific categories. Secondly, things like the role of the environment. So, for example, somebody who's not great at who's got social communication difficulties might struggle at school somewhat. And somebody who's got ritualized behavior would also struggle at school somewhat. But imagine someone who's got both. They're probably going to have an even harder time at school. And that's a sort of situation where a whole bunch of specific characteristics which you can measure individually, by highlighting on how they both occur in some specific individuals, we can demarcate off, hey, this person probably had a really difficult time at school, let's see how that influences them today. It's things like that. And also causally. So a whole bunch of causes will result in social communication difficulties, both internally in your brain and potentially outside as well. A whole bunch of causes would influence this ritualized behavior stuff. Well, those causes can interact with one another. So by adding on like a categorical divide of let's add on a categorical thing to somebody who scores highly here and scores highly here and call it autism, that might highlight causal connections. And so I think this is great. I just think we can add on, and it's great to measure all these things dimensionally. We can also add on, we can add on categorical divides above and beyond it. So to conclude, at least under how philosophers have thought about reality, diagnoses are not likely to be things that we should believe in any sort of concrete sense. And from that, you could conclude, therefore, that they're not very good and we should get rid of them. That, however, my response is science often involves idealized and abstract models that are quite distant from reality, and that's fine. That's how science works. That's not a reason to then chuck out physics. So DSM diagnoses as scientific models, categorical, dimensional, and person-centered as ways of modeling. And the crucial thing is that although I'm defending DSM diagnoses by portraying them as models, no one model fully describes the world. They're incomplete, and so you need to supplement them by other models. So they're better than the critics make out, but they're not enough. They need more things. Thank you very much.
Thank you very much, Sam, for this brilliant speech which outlined psychiatric diagnosis as models. Now the floor is free for questions to Sam. Johanna?
Thank you for a very interesting and thought-provoking lecture, which I fear will interfere with my sleeping tonight. I was curious, do you think the philosophical community might agree that substance use disorders are actually real in another sense, seeing how they are quite predictive and also exist in other species?
Right, so it's fair to say, obviously, of 100 of diagnoses out there, it's difficult to make generalizations because various ones are going to be different. I think substance abuse disorders are probably going to be the less controversial ones, in a sense of you've got a very clear causal thing going on. There's a clear environmental factor, and as I understand it, there's probably more understanding of how that environmental factor then influences both psychology and neurobiology and stuff like that. So maybe that would be a stronger example of the sort of thing that we would consider to be real in a stronger sense, yes.
Thank you very much for an interesting talk. I was wondering on your thoughts, because there are also these networks model by the group in Amsterdam. I'm not sure if you're aware of them,
yes.
But yeah, and they kind of critique the high top based on that it's a kind of pseudo-dimensional system, saying that these categories or these dimensions that the high top outline are actually dimensions of something, if you see what I mean. And the network models are networks of nothing. There is no latent factor. There's only networks of symptoms, so on. So I was just wondering on your thoughts on their critique of the high top. Thank you.
Right, so that's Bohr's boom and the network model. The idea is that one symptom various different symptoms can interact with one another to then create further symptoms that can then interact with those existing symptoms, and you set off a sort of a network of stuff, and that's a causal explanation. So the high top model, as things stands, is not a causal model. It's only a beginning of let's just try and chart things statistically without any causal aspect to it. And I suppose the point I was making well, if someone's scoring highly upon ritualized behavior and someone's scoring highly upon social communication difficulties, those two things can interact to cause more than the sum of their parts. That's basically, I was taking a network model idea and adding it on to the hierarchical taxonomy system. So in a sense, I'm not familiar with the specific criticisms that Bohr's boom is making of that. But yes, if high top is only one particular model, and the network model, which I never mentioned, also explains a whole bunch of stuff. So yes, multiple models is basically, you're right. It sounds like a good point that high top might be missing something and the network model would fill something in, yes.
Thank you for a very interesting lecture. My question is, I think my perception is that you defend the psychiatric diagnosis from a scientific, in the scientific milieu, but we, as most of us, are clinicians, and then the things get more complex. I can see that sometimes the public, the journalists, the patients interprets the diagnosis as something more real than you outline it, and something happens with their identity and with policies in society. Would you defend the use of psychiatric diagnosis also in that sense? So
the actual main thing I'm working on these days is self-diagnosis, and the sort of idea of you either, only autistic people can have lived experience of autism, and so only autistic people can have the knowledge to actually know if they're autistic. That sort of thing is very strongly there. And it's never exactly clear what they're committing themselves to, but it looks like that they are effectively, what I'd say is reifying. I don't know if that's a commonly understood word, but making it more real than it really is. So that's the danger of science. If you take any part of science, be it physics or psychiatry, and make it more real than it actually is, then you start narrowing down what's happening. You start narrowing down your understanding, and you start focusing on some aspects and not realizing you're missing other aspects. And so, yes, the way in which lots of people with a diagnosis seem to talk about diagnoses as their identities and as these things that you've got and as a fundamental part of yourself, I think that seems to be part of a reification process. I suppose I can only draw upon myself. I think autism gives a pretty good description of who I am, but I don't really identify as autistic. Now, exactly what that means you can debate, but I think I can understand, and I think I should understand myself as being autistic without really reifying it as, oh yeah, there's this thing in my head called autism, and it doesn't change over time, and it's a fundamental part of who I am. I don't think that's a good way to think about these things, but that seems to be what lots of diagnosed people are doing.
Last question, it must be brief, Simon Cervenka.
So also thanks, great lecture. I'm just wondering, so in the kind of research where we're trying to use genetics and molecular biology to try to understand causal mechanisms, for instance, what would be your advice on how we should, what kind of outcome we should aim for in those kind of research projects? Because it's very difficult to use all at the same time, I would say, in that respect.
I can't claim any particular knowledge of that field of science, but I suppose my thought is that if we had a situation where 30 different groups were taking 30 different, slightly different approaches to it, not necessarily massively different, but just focusing on different aspects at different layers. So one thing that's important in relation to neurobiology, as I understand it, is different layers of resolution. So you can focus on one layer of resolution and you find one bunch of mechanisms. You focus on a different layer of resolution, you find a different bunch of mechanisms, stuff like that. And also because all mechanisms themselves are quite abstract and idealized, there's, as I understand it, there's literally millions of causal connections going on in someone's brain. You've got to be selective. Have 30 different groups just taking a different angle on this, and have a smaller number of groups of experts, psychiatrists, even philosophers, who sort of sit back and say, well, how does all this work together? And there's not going to be an easy answer to that. There's not going to be a clear way in which it works together and we find the truth, but just some reflection upon exactly how does this model relate to that model? How are they different? How are they getting at similar phenomena or different phenomena?
Okay, I think we should give Sam a great applause for this fantastic lecture.
Thank you.
Thank you all for coming. Och nu är det en kvarts paus och sen fortsätter vi med jätteintressanta program som faktiskt ska handla om diagnostik av autism och katatoni. Så kom tillbaka om en kvart.